This video is going to cover Unit 17-3, Solving Systems of Equation by the Addition Method. Okay, so let's take a look at the example given at the bottom of page 478, where we have 5x plus 2y equals 19 and 3x minus 2y equals 5. Now, the immediate goal is to eliminate one of the variables. Now, we did that the other method by solving one equation for a variable and then substituting it back in. So we had only one variable for one equation. Now, this method, what we want to do is we want to get the coefficient in front of one of the variables, the two coefficients, to be equal and opposite. So let's take a look here. The coefficient in front of y is 2 for both of these. And they are opposite because this one is a negative 2 and this one's a positive 2. So this one is set up right now for the addition method. So if I combine all of the like terms here, I will eliminate the y variable. So let me show you. So we would have 8x, 5 plus 3 is 8, and plus 0y equals 24. So that means we have 8x equals 24. Divide by 8, and I will have x equals 3. So now we have x equals 3, and just like with the substitution method, I pick one of the equations and I substitute that 3 back in. So I will have 5 times x plus 2y equals 19. So this is 15 plus 2y equals 19. Subtract 15. And we have 0, and I have 2y equals 4. Divide by 2, so y equals 2. So the ordered pair solution for this system of equations is 3, 2. So these two lines will meet in the xy plane where x is equal to 3 and y is equal to 2. Okay, so let's take a look at some other examples. I'm looking at page, let's find a good one here. How about page 480, number 16? So we've got 6x plus 4y equals 72, and 7x plus 4y equals 80. Okay, so if we look at the coefficients in front of the y, we have a 4 and a 4. They're both positive. So what I need is one of them to be negative. So I'm going to multiply one of them by a negative 1. So if I do that, I have to multiply the entire equation. So let's take this top one right here, this top equation, and multiply that by a negative 1, and that's going to change the sign on every single term in there. So I will have a negative 6x minus 4y equals a negative 72. Now when I combine all of the like terms, the y's will cancel, so I'll be left with just x equals 8. Then I take my x and I substitute it back in. So 6x plus 4y equals 72. So 48 plus 4y equals 72. Subtract 48. minus 48. And I have 4y equals 24. Divide by 4. Divide by 4, and I have y is equal to 6. So the ordered pair solution here is 8, 6. So this one, we had to go ahead and multiply one of the equations by a negative to make the coefficients in front of the y equal and opposite. Now you could have also multiplied the other one by a negative and it would have come out to be the same. But let's take a look at, let's see, let's take a look at some of them that are a bit more complicated. On page 482, let's take a look at number 21. So number 21 on page 482, I have a negative 7x plus 3y equals 6. And I have a negative 6x plus 4y equals 2. Okay, so what I need is I need to make either the coefficients in front of the y equal and opposite or in front of the x equal and opposite. And it doesn't really matter which. So I'm going to continue with the y's. So I will put parentheses around here and around here. Now, to make these equal, I will multiply the 3 times 4 and the 4 times 3. That makes them both 12. So if I multiply this entire equation by a 4 and this entire equation by a 3, the coefficients in front of the y's will both be 12. Now, that helps me, but what I need is one more little step. And that step is going to be, I just need to make one of these a negative. And it doesn't matter which one. I will make that one the negative. So now I will distribute here. So 4 times 7 is 28x, and a negative times a negative is a positive. 4 times 3 is a negative 12y equals 4 times 6 is 24. Negative times positive is a negative. 3 times 6 is 18x, and it is a negative because the 6 is negative. And 3 times 4 is 12, 12y. And then 3 times 2 is 6. Now at this point, when I combine my like terms, the y terms will be eliminated. So I'm not even going to really write them. So 28 minus 18 is 10x. 24 minus 6 is a, or negative 24 plus 6 is a minus 18. Divide by 10. Divide by 10. And I have x is equal to a negative 9/5. Twelve, 6. Okay, so now we take that x and substitute it in for one of these. So let's put it in for the second one. Minus 6 times x plus 4y equals 2. let's see here, 6 times 9 divided by 5. So 6 times 9 divided by 5. Is that a decimal I can work with? 10.8. Plus 4y. Subtract 10.8. The only reason I made it a decimal instead of leaving it a fraction is because it's just going to be easier to do a subtraction. So 4y equals a negative 8.8 divided by 4, divided by 4, and I have y is equal to a negative 2.2. So my ordered pair here is going to be negative 9/5. You can make that a decimal, comma, a negative 2.2. So let's take a look at some more examples of those. Let's see, let's pick another one that looks good. How about number 24? Number 24. So I've got 0.06x plus 0.08y equals 0.6. And 0.12x plus 0.02y equals 7.78. Always double check to make sure I wrote everything down right. Okay, now to make the coefficients the same, if I multiply the top equation by 2, I will have the coefficients in front of the x the same. If I multiply the bottom equation by 4, I will have the coefficients in front of the y the same. So in either one, it doesn't matter. So let's pick the top one, and let's multiply that by a 2. That will make both the coefficients in front of the x's 0.12. So I need to make this a negative. So this becomes a negative 0.12x minus 0.16y equals a negative 1.2. Now we combine our like terms, and I don't like trying to do the decimals too much in my head. Oh, let's see here. 0.02 minus 0.16 gives me a negative 0.14y. I probably could have done that in my head, but oh well. 0.78 minus 1.2. That gives me a negative 0.42. So divide both sides by a negative 0.14. Okay, so 0.42 divided by 0.14. Negative divided by negative is positive. So that means y is equal to 3. So then I put it back in. Let's put it in for this top one. 0.06 x plus 0.08 y equals 0.6. So this one, 0.06 x plus 0.24 equals 0.6. Subtract 0.24 from both sides. Subtract 0.24, and I get 0.06x equals 0.36. Divide both sides by 0.06. It's not a very good zero. So x equals 6. So the ordered pair solution here will be 6, 3. So that's where those two lines will meet. Now I do want to do one more because I just want to hammer this home. Let's find one where I have to multiply both of the equations by something, if there is one. I already did 21. 20 looks good. 8x minus 2y equals 8. 5x minus 3y equals 12. Okay, so I'm going to stick with the y's here because I want to keep the numbers small. So this top one has to be multiplied by the 3, and this bottom one I multiply by the 2. Now that will get them equal, but I also need them to be opposite. So I just need to make one of them a negative. And like I've said, it does not matter which one. So let's just make that 3 a negative. So let's go ahead and multiply. So we will have a negative 24x plus 6y equals a negative 24, and then 10x minus 6y equals 24. Okay, so the x's, or the y's rather, are gone. And so what I have here, let me make sure I did that right. Yep, I did. I have a negative 14x equals 0. I'm glad I picked this one. So just follow my math. Divide that by a negative 14. That makes that a 1. Divide that by a negative 14. So x is equal to 0. 0 divided by anything is 0. Okay, so I come back up here and I say 8 times x minus 2y equals 8. So what I'm left with is a negative 2y equals 8. Divide both sides by a negative 2. And I have y is equal to a negative 4. So my ordered pair solution here is 0, negative 4.